Discrete random variables. Let's start with a quick review. First of all, a variable is any characteristic of an observational unit which can take on different values. In other words, it can vary. A random process is a process which can generate one of several outcomes at a time. So that's just from back in the last couple note sets, but let's talk specifically about random variables. A variable whose, first of all, to be a random variable, it's a variable whose value is a number. The numbers are associated with outcomes of random events. Okay, so there had to be a random event, it occurred, and it had a numerical outcome. We use a capital letter to denote a random variable, X, Y, Z. If it's cost, I'll use a capital C. If it's revenue, I'll use a capital R. So I usually try to use the use that capital letter that makes sense. A random variable is called discrete if it can take on only isolated points on a number line. So there are a finite number of values, and we can list every possible outcome. Sometimes you'll hear it referred to as being countably finite. So, for instance, can the number of laptops sold by a bookstore each day, we could count the number of laptops that were sold. So to be a discrete random variable, you need to be able to list every possible outcome of that random variable. Every random variable has a probability distribution associated with it. Now, the probability distribution of a discrete random variable lists all possible values of the random variable and the probability of each. Now, to be a valid probability model, what has to happen? Hopefully, you can think back and think, oh, the sum of the probabilities must be 1, and there can be no negative values for the probability. That has to be between 0 and 1 inclusive. Now, one hint here is that usually it is not discrete if a value has many, many decimals. And we'll talk more about that as we go along with this example. Example 6.1, tell whether each is a random variable or not. If it's a random variable, is it discrete? Here we're going to say if it's not discrete, then it is called continuous. A continuous random variable can take on any value, any numerical value. So we'll talk about, like, for this first one, the weight in grams of a randomly chosen bag of plain M&Ms. Well, first of all, is that a random variable? Well, is the value a number? Yeah, when we take a weight, we get a number. So I'm going to use RV to uh, shorten up random variable. Now we have to decide whether it's continuous or it is discrete. You maybe think, well, I'm going to plop those M&Ms on a scale and it'll tell me how many grams there are. So it's discrete. Not so fast. If you get a better scale, could you get a better, more accurate value? And the answer is yes. So when we're talking about weight, height, and distance, we're talking about continuous random variables as a general rule. Remember, let's say that we thought the bag weighed 10.1 ounce, or 10.1 grams, excuse me. Now, 10.1 grams, the scale may only go to tenths of a gram, but in reality, it could actually be 10.099 grams, and we could go further and further and further out. How about the average high school GPA of this class? Now, have you already completed high school? The answer is yes. For this class, is the high school GPA that we find going to differ when we look at this class again, being our class that we're in right now? And hopefully you think, well, no, once we calculate it, it's calculated, we're done. This is not a random variable. It's a value. The class in this case is the observational unit, and the value won't change based on the observational unit because the observational unit is literally just this class. How about C, the number of M&Ms you pick before you pick a blue one? Personally, I like blue M&Ms. I think they taste different than the brown ones. People disagree, but I don't know. Number of M&Ms you pick before you pick a blue one. All right, let's think. I could pick one and it's red. I could pick a second one and it's yellow. I could pick a third one and it's green, so on and so forth until I get to a blue one. So Is it a variable whose values are numbers? Yes. So it is a random variable. Is it continuous or discrete? Well, it's discrete because we could count them. We could count out the number of M&Ms in the bag. So we have it being discrete. The number of questions a randomly chosen student answers correctly on a 10-question quiz. Let's say that you're either wrong or right. Is no partial credit. Hopefully you see right away. Of course, that's a random variable and it is also discrete. Finally, the distance between a randomly chosen person's home and workplace. Well, distance is going to vary. So we choose a person and we can measure distance. It's a random variable. Is it discrete? Well, could we get more and more and more accurate measurements? Yes. This is not discrete, it's continuous. So just as a sidebar, I'm going to put a little space here. We started with variables. And we said they're either categorical in nature or they're quantitative. Remember, categorical can also be called qualitative. Now we can break those quantitative variables into two. They can either be discrete, in other words, countably, we can count the number, we can count the values, or continuous. And that's when there's an interval of values or, and a lot of times when I see decimal points, I question right away, oh, is this discrete or not?